Chapter 13, System of Equations. So a system of equations refers to or more equations that will same set of variables like x and y, x and y. So we deal with two equations in this chapter mostly, and those two equations have the same set of variables x and y, and we are going to solve these two equations using substitution method or elimination method. Depends on the situation, we use the method. It's not all the time substitution or it's not all the time elimination to get the values of x and y or to get the solutions of this equation. So let's get started. So first we have this equation. We are going to solve this equation and we are going to get the solution of this equation. So how we are going to get that? The method just now I said substitution. So we are going to use substitution first for these two equations. I'm going to solve this by elimination as well. So here you can see here substitution. Whenever the variable, one variable is individual like this, like there is no coefficient for this. So you can just transpose this and you get the value of y. So you will get the value of y as -7, +5x. So take this y value and substitute in the equation number 2 here, and then you'll get the value of x. Take that x and substitute it back in this equation 1, x value, you'll get the value of y. So that's how you are going to get it. So same thing they did here, you can see, and then this value substituted in equation 2 here in the place of y, and then after solving we got x, and substituting it back into the equation we got y value as 3. So that's how we got x value as 2 and y value as 3. You can able to get the solution by keeping these two equations in the Desmos as well. So if you keep these two equations in Desmos, you're going to get the value as 2, 3. I mean the solution. So here it's meeting at the two lines meeting at one point and it is a solution. Wherever the 2 points, wherever the two lines meet at a point, that will be the solution. We call that as solution. That solution can be found by substitution and elimination as well as using Desmos on the graph as well. If you just do it on a graph, you'll get it on the graph as well. So now let me tell you with the help of elimination. So how can you do elimination? You can see here, you can do one thing. You can divide the second equation by 2. Then if you divide it by 2, this y values will be almost similar, like plus y minus y. So you can do the elimination, or else you can multiply equation 1. Then equation 1 will turn it into minus 10x plus 2y minus 14. So plus 2y minus 2y will be there. So we can eliminate that y terms and we go ahead. It's up to us whether we want to divide the second equation by 2 or we want to multiply the first equation by 2. Why we are doing it? Because the coefficient of the y is 2 here. So we can get 2 here by multiplying, or we remove this 2 by dividing, so that it will be empty with coefficients for y. It helps us to eliminate. So here what we did, we multiplied it here and we got this one minus 10x plus 2y minus 14. This equation we just multiplied with 2. Now you can see x, y, both y terms are similar, so that we can eliminate by adding or subtracting. It's up to us what we want to do to eliminate it. You can do it. So you cross out this, you end up with -13x minus 26. And then you got the value of x as negative, and 13 times 1 and 2, x value is 2. You got x value 2, substitute this x value 2 in any of the equation, you will get the y value. So you got y value as 2 and 3. These are the two same equations here, just like the previous one, minus 5x plus y equals to -7 minus 5x plus y equals to -7. But we just did it with the help of substitution and elimination here. Both methods are done, as well as we did it with the help of Desmos as well. Now, what is the thing? When to use substitution, when to use elimination. So you can use any of them, but the fastest route is when there is no coefficient. When there is no coefficient, use substitution. What does that mean? Just like this, let me show you. No coefficient. You see in this equation here, there is no coefficient. So you can turn that easily into a y value. So you'll get the value of y and you can do it. When there is no coefficient, use substitution. When matching coefficients, elimination. Like in this equation, the two equations are not matching, but we made them match by doing the operation multiplication. We made them match. Here the y coefficients are not same, but we made them match by doing multiplying by 2. But in some questions, they'll be giving 5x plus 2y equals -7, or else something like -3x minus 2y that equals to 3. If the equations given like this, you can see coefficients are same, like matching coefficients, then you use elimination. That is the best way in that situation to get answer quicker. If coefficients not given, then substitution. No coefficient, use substitution, because you can get the value of x or y easily when there is no coefficient. When matching coefficient, use elimination. Substitution, when coefficients are not matching, here you can see clearly all other coefficients are there, but this one y variable doesn't have coefficient. We are using that to get the value of y, and we substitute. In these situations, we substitute when there is no coefficients. I mean coefficient of a variable, so that we can get the value of that and substitute and get it easily. You can use substitution when equations directly given something like this, your coefficients are matching 2 y variable coefficients are matching. At least one variable's coefficient must match to use elimination. If coefficients are not matching but you want to go with elimination, then you have to do operation. You have to multiply this by 2, complete equation multiply by 2. Then if you multiply complete equation by 2, it turns into like this. Then you can see coefficients are matching. When coefficients are matching, you can do the operation and remove the y values, I mean y variables, and get the value of x and get the x as well. That's it. Now we learned something in chapter 4. So let me tell you that concept what we learned. In the chapter 4, we learned a single equation. What is that? Single equation has infinitely many solutions when both sides of the equations are equivalent, like this: 3x plus 6, 3x plus 6. If the both sides are same in the single equation, then it has infinitely many solutions. This is what we learned, because if you take x value 1, its x value is going to be 1, 2, 3, all of them going to work for this equation. If you keep 1, it's going to work. It's going to be 9 on the left side, 9 on the right side. If you keep 0, it will be 0 on the right side. So it will be 6 equals to 6. So it's going to work for all. But in system of equations, it's not going to be one equation like this. Here only one equation, 3x plus 6 equals 3x plus 6. But in this chapter, system of equations, it's different. It's the same concept. Infinitely many solutions. You can see here the difference is two equations are same. If two equations are similar, same, exactly same, then it has infinitely many solutions. Not like the chapter number 4, which is other types of equation questions. That chapter 4 is other types of equation questions. Not like that, where they're only having one equation. Here we having two equation. That equation looks similar on both sides, but here two equations look similar. It's exactly same. There is no change at all here. Then only these two equations have infinitely many solutions. What do you mean by infinitely many solutions here exactly? So you're going to get, if you substitute x and y, some x value as 1, you will get one y value. Take that value and plot it on the graph, and if you put x value for this equation, if x value 1 here, and you get some y value for both equations, not some, you'll get same x value, same y value. If you take x1 here, you'll get, let's say y will be some value, you'll be getting the same value of y for this as well. If you plot the values of x equals to 1, 2, 3, so on, if you substitute these x values into the equation, you'll get some y values. Do it same here, x values as 1, 2, 3, you'll get some y values in this equation as well. It's almost same. There is no difference in these two equations. Take those x and y values of equation 1, plot it on the graph, and it's in orange color, and take the x and y values of equation 2 plot it on the graph, that's blue color. If you plot them, the 2 points, the two lines what you plotted on the graph will coincide. If they coincide, we say infinitely many solutions. That's what this means. Here we took two equations and we plot it on the graph here, and that the line is the red line and the blue line are coinciding. The equation 1 and equation 2, plot it on the graph, we got only 1 point. Like these two equations have only one solution. What do you mean by one solution? The meaning of one solution is the two lines are meeting at 1 point, intersecting at only 1 point. The two lines intersecting only at 1 point. So these two equations has only one single solution. But here, if you take the x values of this and y values of this, and equation 1 points, if you plot it on the graph, equation 1 points if you plot it on the graph, and equation 2 points you plot it on the graph, you'll get lines, but not like this. They will be on the same line because equations are same. The first equation line and second equation line coincide. It will be having infinite solutions. In the previous case, only meeting at 1 point, so one solution. Here meeting at many points. If you keep moving, you'll keep on get the solutions. So that's why if two equations are same, they have infinitely many solutions. And there is another case where the situation works. In what situation? You can observe carefully. This equation is twice than this equation. So you see, here to here it's double. 3 into 2, 6. 2 into 2, 4. 5 into 2, 10. Just twice of that equation. So if you multiply equation 1 with 2, you'll get same equation. Which means in this situation also, the two equations are having infinitely many solutions. One thing, they must be exactly same. Second thing, if they are doubled, twice, thrice also, equation is multiplied by twice, thrice, or divide by 2, divide by 3, then also they'll be having infinitely many solutions. Those equations will be having infinitely many solutions. Sometimes do not have same coefficients. You can see here coefficients are not same. 6, 4, 3, 2. And constants as well, 10 and 5. Still they're having many solutions. Why? Because the two equations are essentially same. The first equation can be divided by 2 to obtain the second equation. In any form, by dividing by 2, dividing by 3 or 4, you're obtaining the other equation, or multiplying one equation with 2, 3, 4 and obtaining the other equation, same equation, obtaining the other same equation, then we say that those two equations are having infinitely many solutions. If you plot them on a graph, you'll get those two lines meet exactly like this. You can see the red line and the blue line, they are coinciding, which means that red points and the blue points on the graph are meeting at many intersection points. So they have infinitely many solutions. Here there is an example. So in the given system of equations, this is equation 1, equation 2, and n are constants, fine. The system has infinitely many solutions. They mention clearly these two equations have infinitely many solutions. What is the value of m and n? You see these constants are not same. So what we do, we just multiply the equation 1 by 4. If we do that, the thing changes to 4 into 3, which is 12, 4 into 5, which is 20, 12x, 20y, and 4 into 8 is 32. Now you can see constants are same. They already mentioned they have infinitely many solutions. Infinitely many solutions means their equations are same indirectly. If their equations are same indirectly, then their and n values will be same. The coefficient value. Coming to the next thing, this is from chapter 4 again. What do we do in the chapter 4? The system of, no solution concept. You can see in the no solution concept of chapter 4, there will be one equation where their coefficient and x variable term is same, but not the constant terms. Constant terms will be different. That is the thing. A single equation, mainly single equation, has no solution when both sides of the equation are equivalent. Both sides equivalent, but constant must be different. That is the thing you learned in chapter number 4. Other types of equation, But here in this chapter, you will be having two equations, not like the previous chapter, chapter 4, which is having only single equation. That is the difference. and here two equations similar but not their constants. That is the difference. If their constants are different and the rest of the part of the equations are similar, yes, then we say no solutions. What do you mean by no solution? No solution means if you plot two equations, this one, let's put some x value as 1 and you get y value, plot that point, x value as 2, plot that point on the graph, 3, plot that x and y, you'll get some certain y values for the x values what you're substituting for equation 1. Do the same for equation 2 as well, and you plot those x and y values of both equations in the graph, and you see the equation 1 line is this, equation 2 line is this, and they are not meeting at any point. They are not meeting at any point. That's why we are saying no solution. If they meet at single point, we say it has one solution. If they're meeting at many points, you'll get only one line, because one line coincide with other line, the previous one, then you'll be getting infinitely many solutions. They're not at all meeting at single point. The lines are parallel, which means they don't have any solution. Solution means the line or the point, intersection point, there must be something in common between two equations. There is no some point common in between these two equations. So we say there is no solution. Now, here it's again same thing. What do you say that? You see these two equations are almost similar, but the way the coefficient of x and coefficient of y values are not same. But you can see if you just multiply this equation by 2, you're going to get something like 6x plus 2y equals 5. 6x plus 4y 6x plus 4y equals 10, and the other equation same as it is, 6x plus 4y minus 8. So you can see here the given two equations are in a format that one is normal and the other is like twice of that. Like if we do the twice, then they form into a no solution equations. Like you need to identify them after watching it. Okay, here there is a difference is 2. Like if we multiply the first equation by 2, we are going to get almost similar equation. The LHS part is same, but the constants are not same. If this is the situation, we know that these equations have no solution. So you need to be careful in the equation. In the infinitely many solutions also, they must be always the equations are completely similar, but if they are multiplied by 2 or divided by 2, they also infinitely many solutions. They also have infinitely many solutions. You need to be checking that part when you're dealing with the equations. Here also same story. Now let's see this example number 2. You can see this is equation and this is another equation they given to us. These two equations have no solution. They mentioned clearly and they're asking us to find the value of a. We know that these two equations no solutions. These two equations have no solution. If they don't have any solution, their equations must be similar except constants, but they are not looking same. So how can you make them same? Here 12 is there, here 3 is there. Try to check one coefficient. Like here you can't check the coefficient of a and 4 and do something, but you can with this numerical values 12 and 3. So it is 4 times. Let's write this thing as it is, minus ax minus 12y, that equals to 15. And I'm going to multiply this second equation by 4. Why I'm multiplying by 4? So that I'll get 4 4 16x, and then positive 4 3 is 12y. Sorry, no need to multiply with 4. I have to multiply with negative 4, so that I'll get the same y coefficient. So this is going to be negative 16x, negative 12y, and 4 to 8, and negative into negative positive. So you can see now this is almost same. So we wrote the given equations into a bit better form, that similar except constant. You can see constants are not same. And this thing now we need to match it to get the value of a. So you can see what's there in the place of a. It's a is directly 16, minus minus same, x same. So a value is 16 directly. That's how we find the value of a. They gave a word problem. A group of 30 students ordered lunch from a restaurant. Each student gets either a burger or a salad. The price of burger is $5 and the price of salad is $6. If the group spend a total of $162, how many students ordered burgers? So we just going to write the given scenario into equation format. You can see here they can either order a burger or salad. If we consider, let's say, X number of students ordered burger, let's say burger equals X, and the other one which is salad, which is Y. So X plus Y, that equals to how many students? 30 students. That's what we wrote. 30 students order lunch from a restaurant. Each student gets either a burger or salad. Now the price of the price of a burger is $5 and the price of a salad is $6. So the equation turned into this, and $5 into X number of burgers plus $6 into Y number of salad, that equals to total $162. So you can see that equation turned into this way. Now watching that equation, you can solve this thing by either substitution or elimination. It's up to you. If you're trying to solve it by elimination, you have to turn, you need to get a matching terms, but there is no matching terms here. So multiply the equation 1 with 6. Why do we need to multiply equation 1 with equation, why do we need to multiply equation 1 with 6? So that we'll get a matching term. Like if you multiply that, 6 into x, 6x, and 6y, 6 into 30, 180 you get. You can do it, you can multiply by 5 also, so that you will get the value of y. But they said you need to find the value of burger. So if you just multiply by 5 here, if you multiply by 5 here, then you will get the value of y. That takes more time, but you will get it. There is no problem at all. So we are doing by elimination. So this thing will get off after subtraction, and you get 6x minus 5x is x. 180 minus 162 is 18. Directly 18. 18 students got burgers. They are asking burgers, which using substitution method. So the equations we have is x plus y, that equals 30, 5x plus 6y, that equals 162. So I'll just turn this equation y equals to 30 minus x. You can take x equals to 30 minus y also. We need to find the value of x. We need to find the value of burger. Burger is x. So if I go in this way, I will reach my solution in short form. That is the reason. You can go with x also, then you have to find again. If you go with x equal to 30 minus 5, then you have to find x value once you find the value of y. So I'm not doing that. I'm doing a bit faster. So now I'm going to substitute this equation. The thing what we got y value into this, the second equation, 5x plus 6 into y value, which is 30 minus x, that equals to 162. So 5x plus 180 minus 6x, that equals 162. 5x and then this 6x, that's going to be negative x. 180 minus x equals to 162. Transpose x to RHS, transpose 162 to LHS. So 180 minus 162, that equals x. So finally x equals to 18. That's what we need to find. If you go with here x value, if you get, you will find the y value here. If you got y value, you have to substitute back to get the x value. If you got y value here, take it, substitute here, you'll get y value. I mean, sorry, if you get y, substitute, you'll get x value from any equation you substitute. The given equations are 3a plus 6b equals 13 and minus 2a minus 7b, that equals 7. They are asking to find the value of a minus b. First, we have to find the value of a, b, and then we have to find the value of a minus b. So here, in the previous case, it is so easy. We know what we need to multiply with. If you see this equation, to go with this, we know to match up at least one term, maybe x term or y complete thing, we multiply by 6. We know because here 6 is there. If you multiply by 6, we'll get it, or else 5. Here also same scene. We know if you multiply by 2, we can match up the terms. Here also same story, same thing. If you multiply by 2, second equation, we get the same equation almost. But here in this, here 2 is there, 3 is there, 7 is there, 6 is there. How can you match? So in this kind of situation, you just have to multiply this term with this term with this equation. So what I'm going to do is this 3a plus 6b equals 13 minus 2 minus 7b, that equals 7. I'm going to multiply first equation with 2 and then this second equation with 3. So I'm going to get 6a plus 12b that equals 26, negative 6a negative 21b that equals 21. So by doing this, you can see clearly your a are same. Or you can do what? You can multiply the second equation by 6 and first equation by 7. Then you will get b same. So this way you can get any of the terms same. Like if you take the a terms and multiply with both equations, then you'll get a term same. If you do with b, you'll get b same. So now what I'll do, I'll just add these two equations. If I add 6a plus or minus 6a, so this will get off. So what I'll get, 12b minus 21b, minus 21 plus 12. It's going to be minus 9b that equals to 21, 27, 37, 47. So b value equals to 47 by 9, negative 47 by 9. Now we are going to substitute this b value in equation to get a value. Let's substitute this equation. I'm going to substitute in any equation. You can substitute 1 or 2. So I'll just substitute in this. So 3 into a plus 6 into negative 47 divided by 9, that equals to 13. So 3a plus 3 2's, 3 3's. So 2 into negative 47, that's going to be 94, negative 94 divided by 3, that equals 13. And then just doing this all calculation, we get 9a minus 94 divided by 3 equals 13. So 9a minus 94 equals 13 3 is 39. So 9a equals 39 plus 94, that's going to be 90, 130, 134, 133 by 9. Just let me check. 133 by 9. So what do we need to find? We need to find the value of a minus b. So a minus b equals to, a value is 133 divided by 9 minus b value is minus 47 by 9. Minus 47 divided by 9. So that's going to be 133 divided by 9 plus 47 divided by 9. So 47, 7 plus 3, which is, 133, which is 140, 180. 180 divided by 9. So 9 times 1, 9 times 20. So a minus b value is equals 20.